All right, let's find the exact area of this kite. Remember that with exact area, no decimals, we are looking for reduced fractions or standard radical form. So first thing we're going to have to do is we're going to have to use some of our properties of a kite. First, we know that the diagonals are perpendicular, so we're going to have right angles here at the intersection of those two diagonals. The other thing we know is we know that this angle is bisected, so we're going to go ahead and be able to put a 30 degrees right there. Using the fact that it's 180 degrees in a triangle, we're going to get our 60-degree angle up here at the top. Now, the beauty of this is it allows us to use our 30, 60, 90 rules. We have our long side is 18, so we're going to go ahead with half of that for this side, which is going to give us 9. And then for our long leg, we're going to have 9 root 3. That takes care of that side. If we go over to the other side, we still have the right angle here in the center, 45 at that top angle, so we're going to have 45 down here. This is going to allow me to carry that 9 from the leg over to this side. Using another property of a kite, we can carry that top 9 down here to this bottom side. Now that we've done all those old properties, we're going to go ahead and focus in on the area. And on this one, what I typically think of is I actually think of two triangles. I'm going to think of a 1/2 base 1, height 1, plus a 1/2 base 2, height 2. And my two triangles are going to be this side, all right, and we'll call that this one. And the other triangle is going to be over here on this side, and we'll let that be our base 2 and our height 2. So if I go through and I find these individual pieces, base 1 for the yellow, that's going to come down and be this side right here. That side has a length of 18, all right, and that's actually our base for the other triangle as well, so we can go ahead and get that 18 right now. The next thing we're going to do is we're going to get the height for the yellow triangle there, and the height is going to be this side. That height is a 9 root 3. All right. And we can go ahead and get the height for the second triangle as well. And the height for the second triangle is from this segment right here, and that's going to be 9. Now, at this point, we can go ahead and start pushing these together. So we have area equals 1/2 18 times 9 root 3 plus 1/2 18 times 9. So if I clean that up a little bit, I have a half times 18, which is 9. 9 times 9, which is 81. So we have 81 root 3 plus, we have a half times 18, which is going to be 9. 9 times 9, which is 81. Now, these are not like radical terms, so we're pretty much stuck at this point. And we're going to look back to units. There are no units listed, so we'll go ahead with units squared. Now, I told you I'd give you two options. The second option is a formula for the area of a kite. And the area of a kite is actually the same formula as the area of a rhombus. It's going to be 1/2 diagonal 1 times diagonal 2. So if I take that approach, the short diagonal on this one, which is vertical, let me go ahead and highlight that for you. That's this piece right here, is going to be 18. So we'll call diagonal 1 18. All right, diagonal 2 is going to be going the other way, so straight across here. So we're going to have a 9 plus 9 root 3. All right, so now we're going to go ahead and drop this into the formula. So area equals 1/2 diagonal 1, which is 18, times diagonal 2, which is 9 plus 9 root 3. If I go ahead and clean this up, I have a half times 18, which is 9. So we have 9 times 9 plus root 3. We distribute in, and we get 81 plus 81 root 3. From our commutative property, we know that that's going to be 81 root 3 plus 81, which is the same answer we got using the other approach. Again, it all depends on whether you want to think of this as separate triangles put together, or you'd like to think of it using a new formula, which is the area of a kite is 1/2 diagonal 1 times diagonal 2. Thank you.